So how do we use that applet when we have two samples, two means? The same thing happens with proportions. That's not what this video is about. So this is from the problem set out of the textbook on section 9.2, and there's that problem. Of course, you've got all the worked out answers in the back, and you can see how Dr. Stevens does it with the formulas and z-scores and everything. But the point of this video is to get you to use that Rossman Chance applet. Now, the first thing you always want to do with any significance tests is to create your two hypotheses. Also, what's the claim? See, the claim and if I didn't explicitly have it, I would have to write that out. They want us to test the claim that the students who study music in high school have a higher math SAT average than those who do not. And the way they gave us the data, the first sample was the people that studied music, and there's your SAT scores. And here's the people that didn't study music, and there's your SAT scores. So our HO and H1 there's no difference in the averages. Another way of writing this is I could write mu1 minus mu2 equals 0. No difference. And then the claim is that the average math SAT score is higher than the group that study music than the ones that do not study music. And again, we could write that in this form, where if we take the math average of those that would study music, subtract the average of those who do not, that will still be a positive number. If it were a negative number, we'd have to say it's less than 0. Okay, so there's that. Now, what did they give us? Well, here in this table, they gave us the data, and we could certainly calculate the mean and the standard deviation, but Dr. Stevens' textbooks tells us the mean for both of them, and it also tells us the standard deviation for both of them. Now, one thing I just noticed that I didn't notice that he gave us the standard deviation when I was preparing this next image, but all I did is, and suppose he didn't give you the standard deviation. This symbol is the variance, and to get the standard deviation, you just have to take the square root of each of those, and that would give you the standard deviation. Okay. So now how do we substitute all these numbers into the applet? Well, I have to select two means. I have to use that drop down because I have two means. And then you have to count the number in each. And of course, they didn't give us any in this table. But it works out there's 8 people that studied music, and there are 11 people that didn't study music. And I put the mean into each of these. And then I did the standard deviation. Of course, as I said, I did this calculation. I didn't use what they gave us. They rounded the same values. Okay, then once you do that, that's half the battle. And then, here, let me delete this. Then to use that, once you get that in there, you can click calculate, and that'll give you this box and whisker plot of the differences of each. And then you're going to select... tests of significance. You have to make sure you set up your HO and H1, which is why we like to set these up ahead of time. And then once you've got that correct, click calculate, and it'll tell you the t-score, the test statistic. It'll tell you the p-value. If you want to go use a t-score table and find the critical value, you can, but there's nothing wrong with just looking at that p-value, which is a very small p-value. It's less than our 0.01 level of significance, so we can reject HO. It looks like the data does support the claim that students who study music in high school will have higher math SAT scores on average than those who do not. Okay, must be something about that side of the brain. I don't know, but that's not what I'm trying to answer here. Okay, so I hope that helps you use this applet. I encourage you to use it.